Hello everyone, welcome to PM Networking. Hope you all are doing great. Guys, this is fourth video of wireless networking series and I'm expecting you are watching all videos in sequence. Guys, if you have not seen the previous videos, then first please watch day 1, day 2 and day 3 videos. After that watch this video. Only then you will understand it well. Okay, so today guys, in this video we are going to understand channels, like channels under 2.4 GHz frequency and channels under 5 GHz frequency. What are the overlapping channels, non-overlapping channels under 2.4 GHz as well as 5 GHz frequencies. Guys, understanding channels or overlapping channels, non-overlapping channels in wireless networking is bit confusing because good contents are not available on the internet. But I'm damn sure after watching this video, you will have a clear understanding about the channels, like channels under 2.4 GHz and 5 GHz frequencies. Okay, so now without wasting our time, let's begin. Guys, in last video, in previous class, we discussed about the bands, like what is band, what is frequency. Frequency is what? Cycle per second, right? So if a wave is completing, let's say 4 cycle in 1 second, then frequency is going to be what? 4 Hz. And if I am saying 4 gigahertz, it means 4 multiplied by 10 raised to power 9. A wave is completing 4 multiplied by 10 raised to power 9 cycles per second. Okay, and we also seen the difference between 2.4 and 5 gigahertz frequency. Like 2.4 gigahertz is slower than 5 gigahertz, but under 2.4 gigahertz we will have large coverage area, right, as compared to 5 gigahertz. And here we have more radio interference under 2.4 gigahertz. Here we have less radio interference. 2.4 gigahertz signal can cross the wall, but 5 gigahertz frequency cannot cross the wall easily, right? So these are the difference, like basic difference between 2.4 and 5 gigahertz. Then guys, we had discussed about the band, like what is band. So group of frequency is band, like group of IP addresses are represented as network ID. In the same way, group of frequencies are represented as band. Okay, so in last video we discussed some more difference about 2.4 and 5 gigahertz frequency, like difference in term of frequency range, difference in term of data speed, in term of interference, in term of range and device compatibility. Okay, so these are the topics of previous class, guys, and this is topic for the day: channels. Okay, so first of all, before discussing the channel, let me discuss what is interference. Guys, so interference means what? Disturbing, right? In single word you can say disturb, right? So here you can read, interference means when unwanted signal disrupt the communication between devices, right? Unwanted signal means not my signal, genuine signal. If any unwanted signal is disturbing the communication, that is known as what? Interference. Let's say this is my house, and in my house, guys, I'm using internet through a router, that is AP, your access point, and this AP is working on, let's say this AP is working on a channel number 1, right? And my neighbor is also using internet through AP. So in their home also there is one AP, right? And that AP is also working on same channel number. So guys, there is no chance that these two AP can overlap with each other. Soon we are going to understand how these two AP can overlap with each other, right? Because if my neighbor and my both AP are working on same channels, then there is chance of interference, right? There can be disturbance. There can be disturbance because this AP is also going to transmit signal on same channel, and this AP is also going to transmit signal on same channel, right? So there will be overlapping, and in the overlapping area we will have disturbance, and that disturbance is known as what, guys? Interference. Okay, don't worry about it. Soon you are going to understand like how these two AP are going to overlap with each other. Okay, so if someone will ask you what is interference, so interference is nothing but unwanted signal disturb the communication between devices. This can result from overlapping frequencies, as I told you, right? Then there are many other reasons as well, guys, like other electronics devices emitting signals in the same frequency range. Getting my point? Interference can decrease signal quality, right? So if your AP and your neighbor AP both are working on same channel or maybe on different channel, but let's say my AP is working on channel number 1, my neighbor AP is working on channel number 2, then also you will see these two AP can overlap with each other, right? So you have to understand the channels. Like if we are going to set up two AP on a floor, right? So we have to configure these two AP in such a way so that these two AP should not overlap with each other, right? Otherwise we will have slowness, we will have disturbance in the network, right? Maybe disconnected, your device will get disconnected from the AP because of this overlapping. So interference is not good thing, it's a bad thing. It can decrease signal quality, low data rates, right? Or even complete loss of connectivity. Technically, frequency hopping, spectrum modulation and proper channel planning are employed to mitigate interference in wireless networking. So these are different technique which we are using to avoid interference. Getting my point? Don't worry, you will understand frequency hopping as well, spectrum modulation, and this one, proper channel planning. So you are going to understand proper channel planning in this video, right? After watching this video, you can set up these two AP on a floor in such a way so that these two AP cannot overlap between each other. Okay, so guys, topic is 2.4 GHz channels. Read the first point very carefully because it is very important to understand 2.4 GHz channels. This point is very important. What it's saying? It's saying 2.4 GHz frequency band. Again, I am telling you, band is group of frequency. That means it is talking about frequencies, right? So 2.4 GHz frequency extends from 2.400 GHz to 2.483 GHz. So this is range of frequencies in 2.4 GHz, right? Range of frequency. So if someone will ask you what is the range of frequencies under 2.4 GHz channels, so you can say it will start from 2.400 GHz and it will end on 2.483 GHz. And as I told you about the units, so guys, here you can see this 2 is measured in gigahertz, right? And 400, this is in megahertz, right? This is in megahertz, right? So how many frequencies are there in megahertz? Can you calculate it? Yes, this 2 is same, this 2 is same over here, right? In megahertz, first unit is same, 4, here number is 0, and here number is what? 83, that means 84, right? A difference of 84 megahertz, not gigahertz. Okay, so this number is in gigahertz and these numbers are in megahertz. In the same way over here, this number is in gigahertz and these numbers are in megahertz. Okay, so hope the range is clear, guys. Range of frequencies under 2.4 gigahertz. Don't worry if you are getting confused. I'm going to clear your all confusion soon, guys. Okay, read the second point. This is clear. This is nothing but the range of frequencies under 2.4 gigahertz. Now, next point is this band is further divided into sub-bands. This band is further divided into some bands and that is called channels. So if someone will ask you what is channels, what is channels in wireless communication, guys? So channel is nothing but subdivision of band. Band is group of frequency and dividing that group of frequency is known as what? Channel. So hope channel is also clear to you, like what is channel? This band is further divided into subdomain and that is called channels. And these channels are assigned to Wi-Fi devices like your laptop, your mobile, your access point, any other devices to communicate with each others, right? So wireless devices need what? Only channels to communicate with each other, right? And what is channel? Subdivision of band. What is band? Group of frequency. Fine, guys. Now, guys, I'm sure that you have seen this diagram in lots of books on the internet or in your classroom, right? But some people are getting confused, right, after seeing this diagram, guys. Why? Because it's not clear, right? It's not much clear, like what is this, what is this, what is this one, where is overlapping, where is non-overlapping. But don't worry, guys, I am going to break this diagram today, right? After just 5 minutes you will have clear understanding of this diagram. Okay, so these are nothing but channel 1 2 3 4 5. These are channels, right? So there are 14 channels. There are 14 channels in 2.4 gigahertz frequency lip. Now the important thing for you till now is what is channel, what is the range of frequencies in 2.4 gigahertz, right? So as I told you, range is starting point is 2.400 and point is 2.483, right? Now read this point very carefully again. First channel starts from 2.401, right? What is the first channel? This is first channel, this is second channel, third channel, fourth channel, like this. So first channel will start from this frequency 2.401. Okay, first channel will start from 2.401. And guys, this is range of frequencies, right? Range of frequency bands under 2.4 gigahertz. And your first channel will start from here 2.401. Okay, so if someone will ask you what is the band of first channel, right? So it is going to be 2.401, right? And it goes to 2.423, right? Means first channel is ending over here, right? Over here. This is the first channel. Okay, so this point over here frequency band is 2.423. 2.423. That means first channel is occupying how many frequencies? It's occupying 22 megahertz frequency, right? Because you can see now starting point is 2.401, ending point is 2.423, means there are 22 megahertz. That there is a difference between this point and this point is going to be what? 22 megahertz, right? So read the first point again. First channel start from 2.401 and it goes to 2.423. So we can say first channel occupied 22 megahertz. And guys, the middle frequency is known as by central frequency, and your central frequency is nothing but channel, right? So may I know the channel number 1? What is the frequency of channel number 1? So tell me the middle frequency of these 2 points. This is a starting point, this is ending point. So middle frequency is going to be what? 2.412, right? This is the middle point between these two frequency band. So this is channel number 1, right? This frequency band is channel 1. So you can see channel 1, channel number 1 frequency band is 2.412. Now hope it is clear. Okay, so again I am telling guys, first channel will start from 2 point. Again I am saying first channel will start from 2 point. Let me reduce the pin size. First channel will start from 2.401 and it will goes to 2.423, right? So there is gap of 22 megahertz, and central frequency is known as by channel. So central frequency is known as by channel. Then tell me what is central frequency? 2.412. So this frequency is known as what? Central frequency. Okay guys, so you can read the point. First channel start from this and it goes to this. So we can say first channel occupy 22 megahertz and the middle frequency is known as by central frequency, and channel is known as by central frequency only. Channel is known as by central frequency. Okay, so channel number 1 2.412, right? Frequency, this is frequency, central frequency. So if someone will ask you what is the frequency of channel 1, so guys, this one 2.412. Why? Because channel 1 starts from this frequency 2.401 and it goes to 2.423, and the central frequency is known as by channel. So central frequency is 2.412, right? In the same way, second channel will start after gap of 5 megahertz, right? So okay, you tell me, if first channel start from 2.401, then second channel will start from what frequency, right? So second channel will start after the gap of 5 megahertz, right? So guys, if you will add 5 megahertz in this frequency, what frequency you will get? 2.406. Am I right? So this is going to be what? Second channel. This is going to be what? Second channel. Again, third channel will start after gap of 5. Fourth channel will start after gap of 5, right? So second channel is going to be what? This one, right? And this channel will end over here. On what frequency? Again, there is gap of what? 22 megahertz, right? 22 megahertz. So if you will add 22 megahertz in this frequency, right, what frequency you will get? That will be the end point of channel 2, right? So guys, second channel will start after gap of 5 megahertz. It means second channel start from 2.406 and it goes to 2.428, right? So just you need to add 22 over here in this frequency, right? So 2.406 and we need to add what? 22 megahertz over here. So what frequency you will get? 2.428. So this is going to be end point of second channel, right? 2.428. And what is the central frequency, right? If a channel is starting from this frequency 2.406 and it goes to 2.428, then what will be the central frequency? Central frequency is going to be what? 2.417, right? So central frequency is known as by channel. So channel 2 is 2.417, right? In the same way guys, if second channel is starting from 2.406, then what will be the frequency of third channel? Third channel will start after gap of 5 megahertz, right? So if you will add 5 megahertz over here, what value you will get? 2.411. So here value is going to be 2.411. Third channel. So third channel will start from 2411, right? And again, this channel will end after 22 megahertz. After 22 megahertz. So if you will add 22 megahertz over here, what value you will get? 2.433, right? So this channel will end on 2.433, right? So you can read over here, third channel start after gap of 5 megahertz. It means third channel start from 2.411 and it goes, it goes to 2.433, and channel is known by central frequency. So third channel is going to be what? 2.422, right? So central frequency guys over here is 2.422, this one, right? So this is the frequency for channel number 3. right? In the same way you can calculate it, channel number 4, 5, 6, 7, 8, right, like that. Okay, so hope guys now this diagram is clear. So these are, you know what, these are central frequency. These are central frequency. You can see this is what, channel 1, starting point 2.401, end point 2.423, and central frequency this one, and central frequency is known as by channel, right? So channel number 1 works on this frequency, channel number 2 works on this frequency, channel number 3 works on this frequency, like that. Okay, so hope it is clear guys. There is gap means, or you can say the difference between a starting point of a channel and the end point of channel is 22 megahertz. I'm talking about this space, right? Here you can see this space is what, 22 megahertz, and next channel will start after gap of 5 megahertz, right? So let's say if this channel means channel number let's say 8, this is channel number 8. If this frequency is starting from let's say 5, then next frequency will start from where, 5, let's say 5.1. The next frequency is going to be a start from where, 5.6, after gap of 5 megahertz, right? After the point, whatever value you have, that is in megahertz, right? Before the dot, whatever value you have, that is in gigahertz. Okay, so now hope it is clear. Now guys, you can see over here overlapping and non-overlapping channel. See, this is channel 1, channel 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are 14 channels, and all channels are known as by their central frequency. So see, channel number 1 and channel number 2 are overlapping with each other. Yes or no? Yes. See, this is the area of channel 1, and guys, channel of area 2 is what? This one. So there is some overlapping area, right? This is nothing but overlapping area. So if you will connect two AP, right, on a floor, and one is working on channel number 1 and one is working on channel number 2, then guys there will be what? Overlapping. So how many non-overlapping channels are there in 2.4 gigahertz frequency? So you can see over here, one, this one is this one. These are what? Non-overlapping channels. These are only non-overlapping channels. Or you can say channel number 2, channel number 2, then channel number 7, then channel number this one. Like also we can use, but we cannot use channel 1 and channel 2, right? These two channels will overlap with each other, right? I can use channel number 2 or 7, 1, 6, right? If I am using channel 1, let's say I have two AP1, AP2. If AP1 is working on channel number 1, if AP2 is working on channel number 6, will these two AP overlap with each other, guys? No, because you can see this is channel 1, this is channel number 6. These are not overlapping, correct? Right? Then guys, channel number 11 and 14, right? These are non-overlapping. So if someone will ask you how many non-overlapping channels are there in 2.4 gigahertz, what will be your answer, guys? So here you can read more about it. But these channels are overlapping, means interference with each other. So if two devices are using channel from 1 to 5, they can overlap with each other, right? So selecting the proper Wi-Fi channel can improve your Wi-Fi coverage and performance. In 2.4 GHz band, channel 1, 6, 11 are only non-overlapping channel. Not only these, either I can use 1, 6 and 11, or I can use what? 2, 7 and 12, or I can use what? 3, 8, 13, like that. Like that. These are what non-overlapping channels in 2.4 GHz frequency. Okay, so you can see 1, 6 and 11 are non-overlapping channels. Total number of channels in 2.4 GHz is 14. If someone will ask you how many channels are there in 2.4 GHz, guys, 14 channels are there. Okay, so total number of channels in 2.4 GHz is, guys, 14. Total number of non-overlapping channels in 2.4 GHz, 1, 6, 11, 2, 7, 12, or 3, 8, 13, and so on. Like this, you can find the non-overlapping channels. After that, 5 GHz channels. Okay, so in 5 GHz, the available channels are 24, right? We have 24 channels in 5 GHz, and those all are, non-overlapping. Channels are not overlapping. Not a single channels are overlapping in 5 GHz. Okay, so all are non-overlapping, but there is some concept under 5 GHz channel. Let me discuss that. Like here you can see the first point is 5 GHz frequency band extends from 5.150 GHz to 5.825 GHz, right? So this is what the range of 5 GHz frequency. Then guys, 5 GHz contains 4 separate bands. 4 separate bands, or you can say 4 separate uni. UNII. UNII stand for unlicensed national information infrastructure. Like look at this diagram. This is my U. This is my UNII1. This is my UNII2. This is my I2 extended, and this is UNII3, like that. Or you can say we have 4 sections. Okay, unlicensed national information infrastructure. We have 4 different you can say what, separate band under 5 GHz frequency, right? 5 GHz contain 4 separate bands. Okay, first band start from 5.150 and it goes to 5.250 GHz. The second band start from 5.250 and it goes to 5.350 GHz. The third band start from 5.470 and it goes to 5.725 GHz, and the fourth band start from 5.725 and it goes to 5.825 GHz. Okay guys, and you can calculate how many channels are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we have 24 channels under 5 GHz. And guys, if you want to check the channels under 5 GHz, you can Google it, or you can, this is channel number 36, this is 40, this is 44 and 48. This one is 48. So these are 4 channels in first band, right? Like that you can check the channels number in 5 GHz frequency. Or let me do one thing, let me Google it over here in front of you. Look at this diagram. Let me open this one. Yes, here also you can see 36, 40, 44, 48, 52, 56, 60, 64, 100, 104. These are in first section, in second section, right? 100, 104. So these are what? These are non-overlapping channels in 5 gigahertz frequency. Okay, so this is all about the channels in 2.4 gigahertz and 5 gigahertz frequency. Hope this video is helpful for you. If yes, then please hit on like button, guys. If you have learned something from this video, then please let me know in the comment section. It will motivate me to make more videos on wireless networking. So just type yes, I have learned, or just type yes, I will understand that you are saying you have understood the concept, right? It will really motivate me. So if you have learned something from this video, just type yes in the comment section, guys. I will came to know that you guys want more videos on wireless networking. Okay, and last thing, if you have any question, query from this video or from any other video, guys, please let me know in the comment section. That's all for today. We will meet soon in next video. Till then, stay safe. Bye bye. That's all for today.